Hello and welcome to Matrix Inversion. So now we're going to talk about how to take the inverse of a matrix and why we would want to do such a thing. This is section 5.3 for those of you taking the class at UTEP. Alright, so the inverse. The inverse of an n by n matrix is also an n by n matrix that when multiplied by A on either side yields the n by n identity matrix I. Now, if I have 3, its multiplicative inverse is 1/3. 2, multiplicative inverse 1/2. 7/5 has a multiplicative inverse of 5/7. These are easy to find. Matrix inverses, not something that we could come up with instantly. And also, if A has an inverse, it's said to be invertible, but not every square matrix actually has an inverse. And if it doesn't, it's called singular. All right, so let's find the inverse of a 2 by 2 matrix. If A is a matrix, a 2 by 2 matrix, A, B, C, D, isn't that clever? A, B, second row, C, D. Then A is invertible if and only if A times D minus B times C is not 0. What will that inverse be? Whatever that number is, we'll take 1 over the number, so the reciprocal of AD minus BC. And then what do we do here? Notice that these two just switched places. AD and DA switched places. And these two kept their same place, but they switched signs, right? If it was B, now it's negative B. If it was C, now it's negative C. And not necessarily it becomes negative. It's opposite sign. Whatever the opposite sign is what this negative is indicating. Now, this is the easy way. It's the shortcut method. This is the long way. Now, why would I show you the long way? Is because this works for every square matrix to find the inverse. This works for every single matrix out there. The easy way is 2 by 2 only. If you have a larger matrix, finding the inverse, you'll do something like this process. If it's a 2 by 2, I'm all about the little rules, little formulas. But if it's longer, all right, if it's larger than a 2 by 2, we have to use the long process. Let me show you. Okay, first of all, these steps. To determine whether or not an n by n matrix is invertible, and to find the inverse if it exists, we're going to follow this procedure. So let's suppose we have the same matrix, A, B, C, D. First, we'll write down the A by I, or A slash I. Woo! What does that mean? That means A, B, C, D, and then we'll put a line down the middle, and then the identity matrix for a 2 by 2. And then we're going to row reduce. You remember the systems of equations that you saw in Math 1320? What we want to do is, and number 2 is where all the magic happens. 1 is write it. 2 is do the work. And our goal here is to end up with 1, 0, 0, 1. And what happens over here is the inverse. And we call that B sometimes. If A is inverse, so what we do is we try to make it so we're using row reduction. We'll make it so we end up with the identity over here, and what results is our inverse matrix. All right, cool. We could do that. We don't want to do that, so we're not going to at first. We're going to do a 2 by 2 first. Find the inverse matrix if it exists. If A is the matrix 3, 0, second row 0, 1/2. The first thing I'm going to do using our formula up here, I'm going to multiply 3 times 1/2, subtract what I get when I multiply 0 times 0, and that happens to be 3/2. Since that's not 0, I know an inverse exists. What is that inverse? Well, that inverse will be 1 over 3/2. The reciprocal of 3/2 is just 2/3. This 1 over means reciprocal. And if you think of it as reciprocal instead of, oh my goodness, what's a fraction doing in a fraction? That could freak people out. But if it's The reciprocal of 3/2, that's just 2/3. So now I multiply my 2/3 and I switch. Let me see. I switch places of the 3 and the 1/2. 1/2, 3, that 3 is positive. And I change the sign of my zeros. Okay, 0 is not really negative or positive, but for emphasis, I put in my zeros. So we'll multiply 2/3 times 1/2. The 2 cancel. I'm left with a 1/3. 2/3 times 0. This is just scalar multiplication now. That's 0. 2/3 times 0 is 0. And 2/3 times 2. Well, that would be interesting, but I'm multiplying it by 3. 2/3, 4/3, 6/3 is 2. So this is our matrix. This is the one we're looking for. This is our inverse. You could check it by multiplying these two matrices together, and you'll get the identity matrix. All right. Example 2, I have 1, 6. Second row, 6, 6. So I check AD, 1 times 6, minus BC, 1 times 6. That's 0. That tells me right away, inverse doesn't exist. I'm not going to waste my time row reduction. I'm not going to waste my time with this because we have 0 here. So we can't find the inverse. But what happens when it's no longer a 2 by 2 and we can't use that fancy formula? Beginning of the semester, my throat always takes a hit from talking this much. Okay, here we go. So, there's a matrix calculator that I gave you access to. I think this is the matrix calculator I put in your Blackboard shell. You could do some awesome things here. You could add, you could subtract, you could do all sorts of things. Matrix B is over here, but really what I want to do is I want to find the inverse of the matrix 1, 2, 3. Second row, 0, 2, 3. Third row, 1, 0, 1. Once you're on the link, you enter the number of rows, 3, the number of columns, 3, and then you tell it, hey, I want the inverse. Oh, no, that's not true. And then you enter them, 1, 2, 3, second row, 0, 2, 3, third row, 1, 0, 1. Make sure you entered it correctly. And then when you press inverse, that's our answer. A inverse is the matrix 1, -1, 0. Second row, 1.5, -1, -1.5. Third row, -1, 1, 1. Very sloppy, but that's where we are. What was that? It was a -1, and that was a -1.5. There we go. So, boom, just like that, we could have our inverse. And I highly recommend you have access to this when you take your quizzes, and you'll also have access to it on your final exam. All right, I do make matrix calculators available for you. Now, this is a separate thought, although it looks like it got really close to it in the notes. So let me just make sure that we're moving on here. If we want to solve the matrix equation AX equals B, here's what we're going to do. If A is an invertible matrix, meaning A inverse exists, then what we'll do is we'll take AX equals B, we'll find the inverse, let's use purple, no, let's use orange, we're minors. We'll multiply on the left side for both of them. I didn't leave enough room, which happens frequently when I don't think things out. A inverse times A will give us a 1. We're left with an X on the left, and A inverse times B on the right. Notice if we multiply by A inverse in the front, on the left side, we multiply by A inverse on the front, on the right side. Okay, so X equals A inverse times B. So we're going to use matrix inversion to solve the given system of linear equations. Don't you wish you knew this last semester? So I have the system of equations 2x plus y equals 2, 2x minus 3y equals 2, and I take my coefficients, 2 and 1 for my first row. Second equation gives me my second row, 2, -3, those are my coefficients. My variables are x and y, so I make a column matrix of my variables, and my solutions matrix my answers matrix will be 2, 2. In order to solve AX equals B, I'm going to solve X equals A inverse times B. So step 1. Step 1, I enter my matrix 2, 1, 2, negative 3 by first inputting the dimensions, and then the coordinates. I'll find the inverse. Here's my inverse. And what I did is I used the copy to A, so this matrix is now my A matrix. So here's A. I found A matrix, and I popped it right back in, so it was there for me without having to type the values, possibly missing a negative, messing up on a 1 versus 4, or a finger bobble to a 7, you never know. So now I have my A inverse. I can enter my matrix B. There are 2 rows, 1 column. They're 2s. And what do I want to do? I want to take matrix A, which is really my A inverse, right? A inverse times B. I'm going to use the product. And when I multiply these two together, I end up with the matrix 1, 0. But what is that? Remember, that's my X. What's X? That's XY. It's a column. So X equals 1, Y equals 0. My answer is the point 1, 0. And you can check it, make sure it works. This is the slickest way I've ever seen matrix inversion, and I am very thankful for the technology we have as we're doing things like this. Okay. I didn't write step 2 or any of that, just step 1. Here's where we're starting. Let's do the second example, and maybe I can write more. Oh, look, they're already there. So my system of equations is x plus 2y equals 4, y minus z equals 0, and x plus 3y minus 2z equals 5. I see that I have variables x, y, and z, so that's my variable matrix. I see my answer matrix, my B matrix is 4, 0, 5. That is a 5. And now I have to take my coefficients. So in the first equation, my coefficients are 1, 2, and 0. 0z is not shown, but remember we always have to fill in every entry of the matrix, so if it's not shown as a system, it's a 0. Second equation, there are 0 x's. There are no x's, so we'll use a 0 for the x. 1y minus 1 for z, so 0, 1, negative 1. Third equation, we'll have 1, 3, negative 2. 1, 3, negative 2. So step 1, we're going to find A inverse by first inputting matrix A, 1, 2, 0, 0, 1, negative 1, 1, 3, negative 2. Have to know our dimensions first. We want to find the inverse. We're going to copy that over so that it's put right into our new matrix A. We'll enter our matrix B. See, that is a 5. I used it correctly. And then we'll multiply. This is matrix A inverse times matrix B. 6, negative 1, 1. What does that tell me? 6, negative 1, negative 1. What does that tell me? Well, it tells me that X equals A inverse times B, which tells me that XYZ is equal to 6, negative 1, negative 1. And we know that two matrices are equal only if their corresponding entries are equal, right? These are both 3 by 1. X equals 6, Y equals negative 1, and Z equals negative 1, our answer. You could write it in a triple as well, depending on what WebAssign's asking you to input. All right, so that's our matrix calculator. That's how we're going to use it. That's how we interpret it. You could always do it by hand if you prefer. Let's look at a real-life example of things that I don't know much about. So if you're in finance, like this is business calculus, you're probably in business. You know more about this than I do, but I got the math. Even if I don't necessarily follow financial statements and things like that. Inverse EFTs, sometimes referred to as bear market or short funds, are designed to deliver the opposite of the performance of the index or category they track, and so can be used by traders to bet against the stock market. You don't always have to invest in the stock itself. You could bet, you know what, I think, for example, possibly, perhaps you would do an inverse EFT on the new mobile app X, formerly Twitter. Perhaps you thought maybe its market shares would take losses on the transfer of ownership. Maybe not, whatever. The following table shows the performance of 3 such funds as of August 5th, 2015, nearly 10 years ago. Year-to-date loss in a percentage. So this is a percentage loss, 6, 5, and 7% for these 3 funds. You invest a total of $9,000 in the 3 funds at the beginning of 2011, including an equal amount in SH and REW. Your year-to-date loss from the first 2 funds amounted to $400. How much did you invest in each of the 3 funds? Okay, so we're going to take this a bit at a time, just like we did in your previous semester. You invest a total, right? A total is going to tell us an equation, a total of $9,000 in the 3 funds. I'm going to let X be the MYY, Y be SH, and Z be our REW, all right, the amount that we invested. So X plus Y plus Z will give us our 9,000. Next phrase, an equal amount in SH and REW. So Y equals Z. It's a relationship, all right. Your year-to-date loss from the first 2 funds amounted to $400. So we're only talking about the first 2 funds. How much would I lost? It's a percentage. So 0.06 of X and 0.05 of Y, 6%. We always do the math in decimal form. We talk to people in percentages. Humans understand percentages. Mathematicians understand decimals. Be a mathematician. Amounts to $400. So once I have my equations, and I'm going to rewrite this one as Y minus Z equals 0, so I could line up all my variables, my equal signs, my numbers. My equation 1 becomes my row 1. Coefficients 1, 1, 1. The variable matrix, and my answer is 9,000 in B. Y equals Z turns into Y minus Z equals 0, so we have 0 X's, 1 Y, and negative 1 Z, so we'll have 0, 1, negative 1. And that answer is 0. 0.06, 0.05, and then 0, because we didn't talk about Z at all, will give us 400. All right, so we take the words into equations. You got this, you got this. Equations into coefficients, variables, and answers. And then I do this exact same process above. I take A inverse. Step 2, I'm going to multiply A inverse times B. Step 3, I'll end up with X, Y, Z equals 5,000, 2,000, and 2,000. That tells me that I invested $5,000 in ProShare Short Midcap 400 and $2,000 each in ProShare Short S&P 500 and ProShares Ultra Short Technology. All right, even though there's another page, that's it to this video. Inverse multiplication, it actually uses every single thing we talked about. What a matrix is, it talks about your dimensions, it talks about matrix equality. I guess we didn't add any matrices in this one, but we definitely used inverse that we just learned about and multiplication that we had an entire lecture about. You've got this, and if you're a little unsure, don't forget to use the Ask Your Teacher feature on WebAssign. Let me know as soon as you have a question on the homework, that way you can keep moving on. Thanks for listening again.